This is the second part of absolute value inequalities. It's called disjunction. I went ahead and added the inequality symbols at the top. I don't think I did that for the other one. I apologize for that. But disjunction is always going to be greater or greater than or equal to. Okay, so anytime you have these two, you think of these different symbols here. Okay, conjunction, in case you didn't write it on the, obviously you didn't write it because I didn't put it. Go ahead and write it here in the corner somewhere, add it to your notes. A conjunction is going to be the less than symbols, okay? Anyway, so this one is an or statement. We're going to have this piece or this piece. Unlike the and statement, we don't share anything with the solution sets, which means we have this part of the solution set, we jump over here, or we have this one, okay? Notation wise, it's similar. We have x less than a number or x is greater than a number. Same with the equals. So the best way to show this is with an example. I'm going to jump right into one. And because we've done this several times already, I'm giving you one that's a little bit harder, meaning there's an extra step, okay? So if you notice, we have our absolute value. Okay, you can redo that. So these are our absolute value bars, okay? And we have a 2 on the outside, which means that if they're not alone, remember that when we're solving absolute value, whether it be equations or inequalities, we have to isolate it first, which means I'm going to have to get rid of that 2. So I'm going to go ahead and do that over here, which is why I put rewrite. 2x plus 1 minus 2 greater than 5. So I add 2 to both sides, which gives me 2x plus 1 is greater than 5 plus 2 is 7. And so this is the inequality that I'm going to be working with, okay? Just like before, this has a negative and a positive counterpart. Because we are dealing with a disjunction, that means that our negative counterpart is going to be less than our value. So if you look at our graph, this is like our negative part per se. So this is less than the value. This one is greater than the value. So you can also maybe add like a little negative here and a positive here, just so we kind of know what symbol goes with what sign, okay? So I'm going to set it up just like that. So 2x plus 1 is less than negative 7. Remember, we have to make the value negative in this one, okay? Likewise, for the positive one, 2x plus 1 is greater than positive 7. So again, these symbols are being attached to this value over here, okay? So let's go ahead and solve this really quickly. Remember the algebra part, I do a little fast just because of the time, okay? So subtract 1 from both sides. 2x is less than negative 8. Divide by 2. So x is less than negative 4. So this is our first part of the solution set. We're going to do the same with the other side. So subtract 1 from both sides. 2x is greater than positive 6. Divide by 2. So x is greater than 3. Okay, we have opposite symbols, which is a good sign. Now let's make sure they are going in the right direction. So here's our number line. We're going to plot both points, so negative 4 and positive 3. These are both open circles, so let's make sure that that's an open circle. And we're going to see if we have the correct shading. Let's do it in yellow. So this says that x is less than negative 4. Remember, less than means to the left. So I'm going to shade everything to the left of negative 4. So far so good. Our disjunction's looking good so far. This one says x is greater than 3, which means that we're going to shade to the right of 3. So x is greater than 3 is shaded this way. And does this look like our disjunction graphs? Yes, it does. So that means that our solution set for this is going to be x is less than -4 or x is greater than +3. And that's it. Okay, let's go ahead and do one more. We'll do a real quick one so we don't run out of time. Let's say we have something like, I don't know, x plus 3 over 2 greater than or equal to 9. Okay, so this problem doesn't have anything extra, meaning the absolute value portion is isolated, so I don't have to do any kind of rewrite. Okay, so I'm going to go right into the negative and positive of this. So here's my negative, here's my positive. Remember, this one is going to be less than, and this is going to be greater than. So that means an equal to in this case, because this was an equal to. So for my negative, we'll do x plus 3 over 2 is less than or equal to -9, because that's our number that we're looking at. Okay. For the positive one, x plus 3 over 2 is greater than or equal to +9. Okay, so just like before, we're going to get x by itself. So since we have division here, we actually have to multiply by 2 first. Let me move this up a little bit, which gives me x plus 3 is less than or equal to -18. I subtract 3 from both sides. So x is less than or equal to -21. Okay, same with this side. So I multiply both sides by 2, which gives me x plus 3 is greater than or equal to 18. Subtract 3. So x is greater than or equal to 15. We graph it. So I have -21 and 15. These ones are closed circles because of that line. And we have that x is less than -21, which means I'm shading to the left. X is greater than or equal to 15, which means I'm shading to the right. So that means our solution set is x is less than or equal to -21 or x is greater than or equal to 15. So this is indeed a disjunction.